Hello. In this lesson, we will talk about negation, conjunction, disjunction, and exclusive OR. Before starting the actual topic, I will talk about some sentence structure. It's pretty easy. Let's say two simple sentences. 1. I will go to school tomorrow. And 2. I will meet my friend at school tomorrow. If I say merge two sentences and make it in one sentence. So this will be a compound sentence and it will be I will go to school tomorrow and meet my friend. Alright, the conjunction, disjunction, exclusive or concept are pretty similar and negation is slightly different, but let's see what happens. Let P be a proposition. The negation of P, which is denoted by not P sign, is the statement which is called it is not the case that P. Sounds like odd. Let's check out some example. Michael's PC runs Linux. If we make the negation, it is not the case that Michael's PC runs Linux. Alright, we can simplify this. Michael's PC does not run Linux. Let's say if P is a proposition and if it is true that Michael's PC runs Linux, then negation of P would be false. Alright. If Michael's PC actually does not run Linux, so if I say Michael's PC runs Linux, it will be false. Then the negation of P, that is Michael's PC does not run Linux, becomes true. Let's check another example. 2 plus 2 equal 4. The negation is 2 plus 2 not equal 4. So I hope you will understand by this example. 2 plus 2 is actually 4. So it's a true proposition. So negation of P will be false. Alright. If I said 2 plus 2 equals 5, then P will become false. Then negation of P will become true. This is the truth table of negation. If P is true, then negation of P becomes false. And if P is false, negation is true. Alright. Let's start conjunction. As we said, conjunction, disjunction, exclusive OR are something like compound sentence. So we need at least two propositions, like two simple sentences. Let P and Q be propositions. The conjunction P and Q is true when both P and Q are true and false otherwise. Let's check some example. Alex studies computer science is a P proposition and Q is Alex enjoys programming. If we merge them and say Alex studies computer science and Alex enjoys programming, that means you are merging two propositions and make it a single proposition. Alright, then if your first proposition P, suppose Alex actually studies computer science, and for P, Alex does not enjoy programming. So what will happen? P will be true and Q will be false. And with definition, what we learn? both P and Q should be true. Otherwise, it will become false. Let's check the another example. 2 plus 2 equals 4. And Q, 3 plus 1 equals 5. 2 plus 2 equals 4 is a true proposition, and 3 plus 1 equals 5 is not a true proposition. So if you merge them, they will become a false proposition. Alright, and this is the truth table. For both should be true, then P and Q should be true. Otherwise, they remain false. Alright, let's start with disjunction. Let P and Q be propositions. Look at this carefully. The disjunction of P or Q is false when both P and Q are false and is true otherwise. That means if just only of P or Q should be true, and if we simplify this, at least one of P and Q should be true, which means both can be true. What is the exception? Both P and Q should be false. Then P or Q become false. Otherwise, it will remain true. Let's do example. The person who has smartphone can see this video, what I am making right now. Alright? And Q is the person who has laptop can see this video. What does it mean? If a person has at least one of this device, he can see this video. Or if he is both device, he can see the video. But if he has none of those devices, he cannot see this video. And assume that there are no other devices there. Alright. P or Q. The person who has a smartphone or laptop can see this video. And if we see the truth table, P, Q, in the definition, when both are false, P or Q becomes false. Otherwise, it remains true. Exclusive OR. This is my favorite topic. Let P and Q be propositions. Look very carefully. The exclusive OR, denoted by P, X, or Q, is the proposition that is true when exactly one of P and Q is true. Otherwise, this is false. That means only one of P or Q should be true. If both is true, then it will become false. If both are both are false, then P exclusive OR remain false. And you can remember this very easily. What is how exclusive OR? Anyone. Alright. P. I will use all my savings to travel to Europe. Q. I will use all of my savings to buy an electric car. That means the saving can be used either for travel or to purchasing the electric car. The person cannot buy or do the same thing at a time. Alright. So the exclusive OR becomes I will use all my savings to travel to Europe or to buy an electric car. Okay, but I can do both, anyone. And its truth table, if one of P or Q is true, then the P exclusive OR statement is true. Otherwise, it is false. All right, that's all for today. Goodbye.